Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Sustainability and Climate Action at BlueScope. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, BlueScope. BlueScope is a provider of innovative steel materials, product systems and technologies, headquartered in Australia, with operations spread across North America, New Zealand, Pacific Islands and throughout Asia. BlueScope is one of the world's leading manufacturers of painted and coated steel products, and with their strong expertise in steel, provide vital components for houses, buildings, structures and more. With more than 160 operations and sales offices across 18 countries, BlueScope employs over 14,000 people and serves thousands of customers every day, including engineers, architects and specifiers. Strong partnerships and networks are built on BlueScope's most loved and recognised product brands such as COLORBOND steel, ZINCALUME steel, GALVASPAN steel and TRUECORE steel. Today we will hear from two speakers, followed by our live audience Q&A session, and I encourage you to send questions through to our speakers via the YouTube chat box. I'd now like to welcome our moderator for today, Kelly Charlesworth. Kelly is Arup's Energy Skills Leader for Australasia. A strong background in planning and approvals for large infrastructure initiatives and recent focus on sustainability and low carbon economy transition places Kelly at the forefront of the energy sector's transformation. Kelly is currently leading Arup's collaboration with the Australian Government on the National Hydrogen Infrastructure Assessment and has previously held leading roles including the New Zealand Government's Green Hydrogen Strategy and the Hydrogen Hubs report for the Australian Hydrogen Strategy. Please welcome Kelly Charlesworth.
Thank you, Amanda, and welcome again to our viewers. I'd like to welcome our first speaker for today, Philippa Stone. Philippa is responsible for the sustainable credentials of BlueScope's Australian products and engaging with industry on sustainability issues. Prior to working at BlueScope, Philippa led the sustainability strategy of Global Construction Specialist, ISG, and was based in London for 12 years. Philippa is a board director of EPD Australia, sits on the Green Building Council of Australia's Expert Reference Panel for Responsible Products and the Infrastructure Sustainability Council's Sustainable Material Technical Working Group. Philippa has a Bachelor of Liberal Studies from the University of Sydney and a postgraduate certification in Sustainable Business from the University of Cambridge. She is a practitioner, member of the Institution of Environmental Management and Assessment, and a Fellow of the Institute of Corporate Responsibility and Sustainability. Please welcome Philippa Stone.
Thanks, Kelly, and hi, everyone. Before I begin, I'd like to acknowledge the traditional custodians of the land from where I'm joining you today, the Gadigal people of the Eora Nation, and pay my respects to elders past, present, and emerging. My name is Philippa Stone, Sustainability Manager at BlueScope, and I'm delighted to be with you today to talk about sustainability and climate action. I'm joined by my colleague, Chris Page, and this is what we're going to take you through in the next hour or so. I'm going to start with a brief intro to sustainability at BlueScope and talk about responsible products and supply chains, including responsible steel, a new certification scheme for the steel industry. And then Chris is going to do a bit of a deep dive on climate action, taking you through BlueScope's decarbonisation commitments and plans. And then I'll finish up with hopefully some helpful considerations for the specification of steel on projects. I just want to kick off with a brief intro to BlueScope. We are a global steel manufacturer headquartered in Australia. We employ 14,000 people in 17 countries, And in Australia, we operate the Port Kembla Steelworks in New South Wales, which produces around 3 million tonnes of steel per annum. We also have coating and painting facilities, which produce some of the brands that you can see on the slide here. Moving on to sustainability, I think it's important to start with the role that steel plays and will continue to play in a low carbon economy. It is an essential material for renewables, for infrastructure, transport and electric vehicles. But the catch, of course, is that it's emissions intensive and a hard to abate sector. So our challenge is to decarbonise the steel industry while it supports decarbonisation in other industries. And with that in mind, I've included our corporate strategy here, just to illustrate that decarbonisation is at the heart of our business. It doesn't sit as part of a separate sustainability strategy. It is very visible in the transform pillar there in the red, in recognition of the fact that transformation is required for the very sustainability of our business. Underpinning that red transformation pillar are our 5 sustainability outcomes. And these are outcomes based on what is material to our business and to our stakeholders and are aligned with the UN Sustainability Development Goals. And you can see them along the right-hand side there. And so these outcomes cover a range of issues from governance to safety, diversity, inclusion, local communities. But the 2 that we're going to focus on today are numbers 3 and 4. And as I said, Chris will take you through climate action shortly, but before he does, I wanted to talk to you about responsible products and supply chains. And I wanted to start by talking about responsible steel. So responsible steel is the industry's first global multi-stakeholder standard and certification scheme for the responsible sourcing and production of steel. BlueScope is a very proud founding member, and we're currently undergoing certification of our Port Kembla Steelworks in New South Wales. And this is where all BlueScope steel that's produced in Australia is manufactured. And the site standard sets out to do for steel what FSC does for timber. In essence, it's a stewardship scheme. You can see on this slide that for the site standard, there are 12 principles that sites are required to comply with, and they cover the full gamut of sustainability issues from water stewardship and biodiversity to human rights and labour rights, and of course, greenhouse gas emissions and climate change. So the strength of the scheme really comes from its breadth. It covers all material issues in the steel supply chain and importantly requires a commitment to decarbonisation. And in line with that, if we take a deeper dive on Principle 8 by way of an example, you can see that the objective is that corporate owners of responsible steel certified sites are committed to the Paris Agreement, and both certified sites and their corporate owners are taking the actions needed to demonstrate this commitment. And so to meet this, there are various requirements around reporting in line with TCFDs, setting targets, planning, measuring, reporting and disclosure. So that's one example of the 12 principles. They're all similarly set out, as I said, covering a range of sustainability issues. So what are the outcomes? What does responsible steel mean for industry? Well, not only is it reducing emissions in line with Paris, but it's increasing the standards on a whole range of ESG, of environmental, social and governance issues in the steel supply chain. So for example, with mining companies and with scrap steel suppliers. And that really comes out in the requirements around human and labour rights. So for anyone who's interested in modern slavery compliance, for example, responsible steel provides a really simple way of minimising risk in the steel supply chain. I've included some of the responsible steel members here to give you a flavour of how multi-stakeholder it is. So you can see some of the big names in steelmaking there across the top in the likes of ArcelorMittal and Tata Steel. But importantly, civil society members along that bottom row with CDP, the Climate Group and Mighty Earth. And then you have important players in the steel value chain. I've included some of the Australian ones here, mining companies like South32 and BHP, and end users like Lend-Lease. And then finally, to facilitate market recognition and encourage adoption by industry, the Green Building Council of Australia, the Infrastructure Sustainability School, and the Supply Chain Sustainability School. And what we'll see, certainly with the GBCA, is the adoption of responsible steel in the Green Star Responsible Products Framework in the not too distant future. I just wanted to highlight at this point that currently the Responsible Steel Standard is for the certification of steelmaking sites, but due to be published later this year is additional criteria for the certification of steel that's manufactured from those sites. So this criteria will take a deeper dive on two key issues: the responsible sourcing of input materials like mined materials and scrap steel, and the greenhouse gas emissions profile of the steel, including thresholds that need to be met in order to be certified. As I say, development is well underway and we expect it to be published later this year. I also wanted to mention Steel Zero, as I thought it would be an initiative that's of interest to many of you. It's essentially a buyers' alliance for steel, sending a market signal to manufacturers for a demand for net zero steel by 2050. It's been developed by the Climate Group in conjunction with Responsible Steel, with an interim target of 50% of steel to be responsible steel certified by 2035. You can see some of the early adopters on this slide. And then finally, I wanted to touch on EPDs and Eco Labels. I imagine many of you are familiar with these documents, but for anyone who's not, we've published a number of EPDs, or environmental product declarations, with more to come this year. And these are documents which outline the environmental impacts of our products based on a life cycle assessment, or LCA. So if you're doing a project LCA, then an EPD will give you a credible, robust, third-party information about a product's impacts for a range of environmental indicators, and including the all-important global warming potential. And then last of all, I've included Global Green Tag Green Rate certification here, just as a note for anyone looking at Green Star or IS rating projects in particular. Specifying products that have EPDs and eco labels like Green Rate can be a simple and cost-effective way to earn points under these schemes. I am going to leave it there for now and hand you back to Kelly.
Thank you for your insights. I'd like to welcome our second speaker for today, Chris Page. Chris has over 28 years of experience in the iron and steel making sector. He has extensive knowledge of manufacturing processes and technologies, having held several leadership roles across BlueScope's steelmaking and coating and painted manufacturing operations. This included a 3-year stint heading primary operations and engineering in New Zealand Steel. As head of new technologies in BlueScope's climate change team, Chris and his team are working with teams across BlueScope's global operations to drive smart solutions in the adoption of emissions reduction technologies. Please welcome Chris Page.
My name's Chris Page. I'm the Head of Future Technologies for BlueScope. And I've just started a new role, and the role is to help BlueScope decarbonise its steelmaking activities across its portfolio. So today I'm going to introduce you to the ideas that sort of will make that decarbonisation activity occur, and how we're going to approach the technology side of that within BlueScope. I'm going to play a short video for you now to give you an outline of our company's climate change action.
We're excited to be introducing BlueScope's first standalone climate action report. For BlueScope, climate action is a key to our purpose to strengthen our communities for the future.
We have developed a climate strategy that will guide our activities across key focus areas. By 2050, we've set a goal of net zero carbon emissions across our operations. In 2018, we set a medium-term steelmaking emissions intensity reduction target of 12% by 2030. We are now introducing a second target of a 30% improvement in non-steelmaking greenhouse gas emissions intensity by 2030.
To pursue our decarbonisation pathway, we anticipate capital requirements of an estimated $300 to $400 million over the next 10 years. This includes an initial allocation of up to $150 million over the next 5 years to deliver on our mid-term commitments.
In the mid-term, for our 2030 targets, our focus will be on optimising our existing operations and processes. To prepare for the longer term, we'll continue to explore multiple process pathways so we can understand how they might apply to our existing operations. Inevitably, the outcomes will depend on how these technologies, energy and raw materials availability and policy evolve.
We know that we don't have all the answers, and that's why we've been working with our partners across the industry and from research and academic bodies to see which emerging and breakthrough technologies can support our decarbonisation pathway.
We're excited and optimistic about what the future holds. Through the great work and innovation of our people, we're already underway with emissions reduction, and we're ready to collaborate with all stakeholders to work towards a more sustainable global steel sector.
Okay, so having seen what our activities are and what our goals are within our company, there's got to be some significant decarbonisation enablers, particularly on the technology front, which are going to enable us to decarbonise the steelmaking process. Now, when we've thought about how that process is going to occur, it's become quite clear to us that there's sort of 5 key areas that we're going to need significant movement in. The first is technology evolution. The processes that will produce a decarbonised steel product actually don't exist today and are under development. So as a company, we're looking at how we can be at the forefront of how that technology gets commercialised and then implemented. We're also going to need a huge amount of renewable energy. It's pretty clear to us that no matter what path we go down, green electricity particularly is going to be absolutely key to the decarbonisation of most industries. And from us, we're not only going to need a little bit of electricity, we're going to need a lot. And a key to that for us is that it's got to be firmed renewable electricity. And so that's 24/7. We can get access to good quality, renewable and cheap electricity. Another key enabler within the industry is going to be hydrogen availability. At the moment, hydrogen is a fledgling industry. We're keen to be involved in the development of that, particularly in the Illawarra. But we're going to need extremely competitively priced hydrogen and on vast quantities. So I'm going to talk a little bit more about what that means for us as a company. Now, the reason that hydrogen wants to be available is that it's considered within our industry that a genuine pathway to decarbonisation is through the DRI, or direct reduced iron pathway, and green hydrogen will be used in that path. Raw material supply is going to be critical. So it's not only the types of raw material we're going to need for the future, it's actually getting access to the current raw materials like coal up until that transition is made. So already there's quite a bit of pressure on governments and industry to decarbonise, and whether or not new coal mines or new coal faces can be developed is becoming a significant question within our industry. And then beyond that, being able to get the material which is direct reduced iron grade is going to be critical as well. And at the moment, only about 15% of the seaborne ores that are available are that type of ore. And specifically, the ore that we use in Australia is primarily from the Pilbara. And that Pilbara ore at the moment is not amenable to the DRI process. And finally, policy support. It's going to be critical that government policy will assist investment in abatement and make sure that there's a level playing field. So just to consider what that means for BlueScope, we've kind of got two targets in mind around how we're going to approach this. We have a 2030 target and a 2050 target. The 2030 target is to achieve a 12% intensity reduction by that period. Now, it may seem like a modest change, but it's actually because at the moment the technology really doesn't exist to significantly decarbonise the processes that we have in place. So our focus in the first sort of up till 2030 period is about improving the energy and process efficiencies that we already have in place, looking for other low carbon energy resources such as biochar and hydrogen. We're also going to use some of our indigenous fuels to replace some of the carbon that we already use. And another sort of key enabler in this, and it's a key enabler across our whole industry, is actually recycling scrap. So at the moment, the process that we use, we're looking to maximise the amount of scrap that we can thermodynamically use in our process. And then going forward, we're looking at what technologies we can employ to either preheat or pre-melt further scrap so that we don't have to reduce that iron ore, because it's through that reduction process that most of the CO2 is actually emitted in our industry. In the meantime, we've got to look at our longer term horizon, and that's a target of getting to net zero by 2050. Now, we need to be in that place now because all these technologies are emerging, and it's certainly not clear which will be the predominant technology in the future. But to give you an idea of the things that we're sort of observing and making sure that we're keeping a close eye on, we do believe that hydrogen DRI will be a key to that. Now, DRI as itself, or direct reduced iron, is already a process that is significantly used in the industry as producing millions and millions of tonnes across the place. At the moment, it represents about 5% of the iron that's made within our industry. Now, pretty much every steelmaker in the world at the moment is looking at how they can expand that process, but also how they can convert it to hydrogen. So at the moment, the way the process works is you get natural gas and you stick that through a very high quality ore, and that natural gas is reformed into both carbon monoxide and hydrogen. And it's both of those molecules that do the work on the oxygen part of the iron ore and take it away from the iron, leaving iron. Now, the DRI process is a solid process, and that's why high quality ore is required. If there's got some impurities in that, that impurity will stay there because it is a solid state process. It doesn't go anywhere. So then when you put it into the next stage of the process, in this case, either an EAF or in what we're looking at, a melter BOF, you have to get rid of that slag. Lower quality ores, the reason that the Pilbara type ores aren't considered as suitable for the DRI process is that they have a higher gangue content. That gangue content has to be removed. If you put it in an EAF, electric arc furnace, that will overwhelm that electric arc furnace and render it very inefficient, needing a lot more electricity to get the steel yield out of it. So for those reasons, like, we are looking together with Rio Tinto to see if we can solve the Pilbara ore problem through the DRI process. And a way to do that is that there's an interim step called the melter, which is a process that we have in our New Zealand steel operation, which we can then remove the slag out of that DRI product and then move that onto what we currently use, which is a BOF. So at the moment, most of the world use a blast furnace BOF process, which is a basic oxygen furnace. And if we're able to do that, then it actually means that a lot of infrastructure in steelworks won't need to be rebuilt because a lot of steelworks already have that BOF set up. If we had to convert to EAF, we're looking at a couple of $2 billion to change over as well. Now, on the other technology side, There are other emerging technologies that we're going to be keeping a very close eye on, and those things might include things like molten oxide electrolysis and CCUS. But what I would say about both of those technologies is that they're at a very early stage in development, and we're sort of thinking that they're many decades away, whereas DRI melter are processes that are in place today, and we can look at commercialising them much more rapidly. So let's talk about the technology challenge that we're going to face within this industry and how that's going to be shaped. Now, this graph shows the crude steel production by process as it was in 2020. Now, the dark blue represents the blast furnace BOF process, basic oxygen furnace process, which is the predominant technology that exists in the world today and makes over 70% of current steel that's produced. And the biggest sort of fleet of those blast furnace BOF steel plants are in China, and they're relatively new. They've all been built in the last 20 years. So there's a significant barrier to just converting to electric arc furnace-based scrap melting. Now, so because of the huge sort of economic commitment that lots of places have made towards this blast furnace BOF, without the right incentives in place, these transitions will not occur. It costs many billions of dollars to make a steelworks, and to sort of turn that around overnight is not going to happen quickly. And apart from that, the blast furnace technology is actually a 500-year technology. So it's very well developed, it's extremely efficient and well understood. And so for countries, particularly like China, who've only recently invested in that, moving away from that could be financially very difficult. Now, the other reason that EAFs aren't the predominant form of making steel is that there isn't actually enough scrap in the world to be able to meet the demand for the product. So generally speaking, the easiest way to make steel is through an EAF. So where it's possible, most places do revert to that EAF process. Take, for instance, us in Australia. So Port Kembla has a blast furnace BOF and have been in that technology for a long time. Now, if we wanted to convert to EAF, we have a simple problem about doing that. There just isn't enough scrap to do that to meet the demand that our customers have on us. So we are absolutely focused on how much we can recycle scrap because it is the easiest solution to decarbonise the industry. Unfortunately, it's not going to provide the solution that the world's demand for steel will create. And when I talk about demand for steel, I mean, there are other materials that people could use, but it is steel that is going to power the renewable energy transition that we're going to go through, because all those processes, whether it's solar or wind particularly, are heavily dependent on steel products to be able to develop the industry on the scale that's going to be required. Now you can see there's a very small area of grey, which is other, and that basically represents the DRI processes that are in the world. So as you can see, mostly steel, about 70% of it is made via the blast furnace BOF, 25% is made through the EAF process exclusively, and then about the last 5% is made through the DRI process. Now, I'm going to give a little bit more detail about these breakthrough technologies and a bit more focus on the hydrogen DRI EAF process. So we're going, there's a couple of problems that I need to talk you through which sort of help understand why some people are going to DRI EAF, whereas BlueScope in particular are looking at the DRI melter BOF. So the point of the hydrogen DRI is that the hydrogen will replace what is currently used, which is natural gas. Now, there are some issues with that changeover. Now, the fundamental change that occurs here with the iron ore is that either carbon or hydrogen strips off that oxygen atom off the iron ore. Now, both of those elements, carbon and hydrogen, can reduce iron ore to iron. There are fundamental differences in those reactions, however. So when you use carbon, the chemical reaction is exothermic, so it actually produces heat. When you use hydrogen, it's endothermic, so it actually absorbs heat. Now, the reason that that's significant is you actually still need energy to make a molten product. And so the reason you can't use hydrogen as opposed to coke in a blast furnace is that the blast furnace process is a liquid ion process. If we put too much hydrogen, that liquid will turn to solid and you'll have a block furnace. So it just won't work. In the DRI process, however, you put in a pellet product, which is porous, and the gas can pass through that, and you end up with a solid iron product. Now, it's mostly metallized, so you still have some impurities in it, which if the quality of the iron ore is good enough, you don't have to do a lot of work to. So primarily what we're speaking is if people want to use the hydrogen DRI EAF process, they have to have a high quality ore, and that's typically called magnetite iron ore. Now, magnetite iron ore has a higher iron content, a lower residual sort of content, which enables it to not create a lot of slag and therefore amenable to the electric arc furnace process. But at the moment, of what's mined in the world, only about 15% of what is mined is magnetite. And specifically, most of the ore that comes out of Australia is what's called hematite, which is a slightly lower iron content, but it has quite a bit more alumina and silica in it. And if you put that in an EAF, you'll create way too much slag, which you'll all have to heat up, and you won't get a lot of volume out of the furnace, and you'll be spending a lot of energy melting that slag as well. So for many of us looking forward, we're not going to be able to get access to an abundant supply of magnetite. We're going to look to this DRI melter BOF process. Now, one of the advantages that BlueScope has in this is that we're actually been operating melters in New Zealand for the last 50 years. So we've got a lot of experience on how a melter works. And so together with Rio Tinto, we're hoping that we can find a way to use the lower grade ores that are predominant in the Pilbara and use the melter process, which is a submerged arc furnace process, which will remove the unwanted gangue material from that ore. And this also enables us to continue to use the BOF caster setup that we've already got in place. So for us, we're spending a bit of time planning about how we're going to do a pilot plan on that scale to determine how to make sure that we get that process correct, the right transition between DRI to melter to BOF. We also believe that we are going to need to use a bit of carbon in that process. So what are the alternative fuel processes that we can use, whether that's biomass or some other process which we can use other off gases from industrial processes to put some carbon back in to keep that liquid iron running. If I know a lot of you are engineers, so if you remember back to your materials university studies and you think about a phase diagram, the most famous phase diagram is the iron-carbon one. As you put in a tiny bit of carbon, the melting point of iron comes down quite rapidly. When you've got no carbon in it, the melting point is somewhere up near about 1500 degrees Celsius. You put in about 3% carbon, that comes down to about 1200. So a lot less energy is required. So we believe that you'll still want to be using some carbon in that process. So how are we going to do that? What are the processes we need to develop to do that? And where are we going to source that carbon from? In terms of the other things that we're looking at, direct electrolysis, it's a very sort of early stage process that they're trying to do some very small scale pilots at the moment. That's going to require a huge amount of electricity. We're going to need a huge amount for hydrogen. We're going to need even more for electrolysis. Now, it's a lot simpler process, and if the energy industry does sort of take off in that trajectory on a huge rate very quickly, potentially that will come into play. Much simpler than creating hydrogen, but also, I guess, it's not relying on the chemical reaction to deliver the product. It's actually relying on energy input to break down the molecules, the iron ore molecules. So It's going to require a huge amount of energy, and it's still in the very early stage technology. Carbon capture and storage, I guess this is something that people are still looking at. We're not naturally blessed with opportunities around carbon capture in New South Wales, particularly locally around where we are. So we see probably not so much the storage, but the utilisation aspect of that as being interesting. And certainly there's a lot of technologies that are in that utilisation and converting CO primarily into other useful either fuels or other energy processes. So we're keeping a very good eye on that as well. So let's talk about green steel and what it will take. So this is just to give you an idea of the scale of the change that's going to be required for our industry to get there. We're going to need technology evolution. So you know, if you think about the, you know, we're currently using a blast furnace process which is 500 years old, very well understood, very efficient, and everyone across the world knows how to use it very well. We're going to go to a process which isn't well used, not well understood, obviously very limited in the types of ores that are currently being used in that process, and then the relative economics of then putting it into something like a melter or some other additional process to be able to create the right amount of steel is going to be very challenging for all of us. So, you know, thinking that we're going to develop new technologies in a very short time frame is unrealistic in our opinion. And we do believe that it can be done rapidly, but it's not going to take days or weeks or years. It's going to take potentially decades to get to that point where it will be commercially viable. Renewable energy. We need access to huge amounts of affordable and firm renewable energy. Just to give you an idea of the scale that's required, at the moment, the Port Kembla Steelworks is the second largest user of electricity in New South Wales, and we typically take off about 100 megawatts off the New South Wales grid to run our various processes. If we want to convert to hydrogen DRI, we think we're going to need 1,500 megawatts. So we're going to need 15 times the amount of the current electricity that we use. And not only do we need it 15 times what we currently use, which is already a huge amount, it all needs to be renewable and it needs to be available 24/7. And that's a big question. And as you can see, if I'm using 15 times what is already a significant part of our cost structure, it's going to change the economics of that process as well. So not only do we need a lot of it, it needs to be really cheap. Now, certainly solar is headed in that direction. Solar is headed in that cheap direction. Now, the issue with solar is the intermittent nature of it. It's great during the day, particularly in summer. At night, it is not a reliable form of electricity. And we already have a solar farm in New South Wales. So we're getting a lot of experience around the vulnerability that using solar has to your energy profile. So we're going to need to be able to invest in other sources of energy, such as wind and hydro and whatever other renewable technologies can be developed in the meantime, but also on huge scale. Raw material supply, I've sort of touched on that already. Not only do we need the high quality ores in the future, we need to determine if we can get technology which will enable us to access the ores that are currently available. But also, we're going to need to be able to get coal until that transition is made. And policy support. So certainly it's been great to see that most of the governments around are absolutely fascinated in trying to decarbonise in the last year or two, which is very, very helpful. Both federal and state in New South Wales have certainly come to the party in trying to fund. In fact, the New South Wales government has announced a $750 million fund to help industry to decarbonise some of the hard-to-abate industries. So we're looking, at how that might be able to support some of the activities that we're going to be doing over the next little period. And so it's not just going to be direct funding, it's going to need to be policy as well. So if you think about a trade-exposed industry such as steel, the policy settings need to be right to make sure that people aren't unfairly putting steel into Australia, which doesn't have the sustainability or environmental or climate change records that perhaps the steel that we will make here. So a lot of people will ask me, why don't we just use scrap steel? I'm going to show you that. So if you look at this graph, the issue about just using scrap is that there simply isn't enough to meet demand. The steel industry has grown dramatically in the last 50 years, and it looks like it will continue to grow quite significantly as countries like China and India increase their per capita consumption. So once that starts to occur, we do believe that more scrap will become available. Nonetheless, you'll still need virgin iron ore units to supplement the amount of steel that's demanded to meet the standards of living that we require in a modern age. So steel is certainly a material which is fundamental to the economic transformation of any country and their lifestyle. So we always will see that there will be a need to bring in virgin iron ore units into our industry. So in terms of what is BlueScope specifically doing in this space, I'm just going to touch on a few of the things that we're really sort of trying to push along in the next year or so. So in the last 6 months, we've been able to establish a couple of memorandum of understandings with a couple of significant players in industry, specifically Rio Tinto and Shell. And we've also been collaborating with many other partners to look at what our decarbonisation options are and how we're going to progress to that net zero goal. If we think about the hydrogen DRI process that I talked about, we have a collaboration with Rio Tinto in place. We've signed an MOU last October, and we're going to explore a couple of sort of different options for us and them. And the priority options are going to be around developing a hydrogen direct reduced iron melter. So producing these low emission iron feed for consumption at Port Kembla. We're going to do it in Port Kembla. But what we're planning to do is how do we convert that lower iron content Pilbara ore using green hydrogen. So at the moment, there's a couple of issues. One, how to use those hematite ores in the DRI process isn't understood, and hydrogen is just too expensive. So we can't do it on scale. We're going to do a pilot plant. It's probably not appropriate to do it on scale yet, given the status of where the technology is at the moment. So we're planning to build a pilot plant. We're currently in the process of commissioning studies to look at the configuration that we could build in Port Kembla to make sure we get a very good understanding of the technological and economic aspects of that hydrogen DRI melter process, utilising both Rio Tinto's experience with the DRI process and BlueScope's experience in utilising melters and steel making. The second collaboration I'd like to talk about is with Shell. Now, to make this hydrogen DRI plant, we're going to need a lot of hydrogen. So we've signed an MOU with Shell in December to look at two specific projects that we're going to develop in Port Kembla. The first one is a 10 megawatt pilot hydrogen plant electrolyser, which we're going to hopefully run out of Port Kembla. We're looking at a couple of options around that. We're looking at how we can, one, make that affordably, but also what are the potential end users so that we can at least seed the market in New South Wales and get things started. So we're going to be using the hydrogen in our blast furnace. There is the option of putting a limited amount of hydrogen in the blast furnace, and we're going to test the boundaries of that using that pilot electrolyser. And then beyond that, we hope to then grow that industry through other means, such as developing transport options. So we're going to be encouraging other companies to convert to hydrogen fuel cells on trucks, particularly. And we're also going to be looking at how much natural gas blending can be done with hydrogen as well. So potentially we can start behind the meter, but certainly we're in preliminary discussions with other partners to look at how that might work as well. Now, there are some other potential off-takers in the Illawarra. There is a potential power plant being built across the way from us and in the port, and there is already a hydrogen gas turbine built at the Tallawarra B site, which can take some hydrogen as well. So we're looking at who around our area might be willing to start the market development of a hydrogen industry. And then once we get, we've sort of saturated that 10 megawatts, we'll then plan to grow that in steps to enable us to continue to lower the cost of hydrogen that we're going to need. Now, we're starting with 10 megawatts. We think that in the blast furnace we could use potentially up to about 250 megawatts. That's to be proven, but up to that much could be used. And then if we want to move to hydrogen DRI on a commercial scale, then we're going to need something like 1,500 megawatts. So this is really a pilot to get the hydrogen market moving in to help us lower the cost and readiness for scaling up in the near future. So we'll be working on a hydrogen hub concept with Shell as well. So hopefully you've got a sense of what it is we're trying to do here in BlueScope. There's a lot of detail behind all of the things that are in there, and I guess I'd like to thank you for listening, and I'm happy to take any questions. So I think I'm going to hand it back to Pip now, and after that we'll go through any questions you might have about any of that.
Thanks, Chris. And with that fantastic context provided by Chris, I'd like to finish off by providing what I hope you'll find helpful considerations, particularly for the steel specifiers among you. Certainly, the question that I'm asked most by architects and engineers is, what is the embodied carbon of BlueScope products? And that one I can usually answer pretty quickly by pointing them to our EPDs. This question, of course, is quickly followed by, how can we make that number smaller? And the question is coming from a good place. We need to rapidly reduce the embodied carbon in our buildings and infrastructure. The challenge, as Chris has explained, is it's not a simple exercise. There's no separate steel manufacturing process we can adopt right now, or material inputs that we can include that will drastically reduce emissions. What we can do and what we are doing is reducing emissions in line with our 2050 goal and our decarbonisation pathway. But back to the question, you have embodied carbon targets to meet on your project. What can you do? Well, first and foremost, you start with design, and let us help you. Come to us at an early stage on what we can do for you around dematerialization through high-strength steels. Spiros Dallas in our hot rolled products team is going to be joining Chris and I on the panel shortly, and he and his team are on hand to talk through any specific project requirements and really help you in that design process to achieve those lower embodied carbon outcomes. And then when you have your design, the next question naturally becomes, which steel has the lowest global warming potential? And what we're finding is specifiers comparing EPDs and looking for the lowest number. And while this approach may seem to make sense on a project by project basis, I urge you to consider the bigger picture. Because as Chris has explained, the easiest way to reduce emissions is to use scrap. But there simply isn't enough scrap for the world's steelmakers to switch to scrap-based EAF steelmaking. And what you're doing by specifying steel with low emissions based on a particular steelmaking technology is potentially creating perverse outcomes and simply shifting the burden around the world. If we want to reduce embodied carbon as an industry, then we need to focus on primary steelmaking. Chris mentioned it's currently 70% of global production, And that's where we need to focus our efforts if we collectively want to limit the effects of climate change. So with that in mind, some of the things that you can consider when looking at steel are the climate commitments and decarbonisation pathway of the steelmaker. Great if they have a target, but what is the plan that goes alongside it? And what about investment? Just how committed are they to decarbonisation? What are they doing in the R&D space, and how transparent are they being with their credentials? And finally, if you want to know what good looks like, then look to Responsible Steel, which has done all the hard work for you. I wanted to leave you with a bit of a signpost to an organisation called MECLA, or the Materials and Embodied Carbon Leaders Alliance. Seed funding was provided to this organisation by the New South Wales government, but it's national in scope. And it's a coalition of organisations committed to accelerating the supply of low-embodied carbon materials in Australia. There are a number of working groups within MECLA, and BlueScope is heavily involved in the steel working group. And we've published this low-embodied carbon steel explainer document that you can see parts of on this slide. If steel or embodied carbon are areas of interest, I'd encourage you to check out MECLA and look at some of the published resources. There's lots more there beyond steel also. And then for any further information on BlueScope, we have lots of information publicly available, including our climate action report and sustainability report, and also our modern slavery statement, if you're interested in the social side of sustainability. So thank you very much, and I will now hand back to Kelly to kick off the Q&A.
Thanks, Philippa, and thank you, Chris. They were two very interesting presentations. Our speakers will now come together to take questions. So if you'd like to submit a question, please do so via the chat box. We've already received quite a number in already, which is great. And please ensure you provide your name and who you would like to field the question. I'd also like to welcome Spiros Dallas, who'll be joining us for the Q&A session. Spiros is the National Manager, Engineering Manager with BlueScope. His current role has a focus on efficient steel-framed project delivery in multi-storey buildings and infrastructure projects. He has extensive experience in considering designs at the early stage and providing steel solutions, substantially reducing costs for the construction. He holds a Bachelor of Engineering, Structural, is a Fellow of IEOST, and has held a number of advisory and industry roles in the steel construction arena for over 30 years. Please welcome Spiros. Okay, there's our panel there. We did actually receive some questions on registration that we're going to begin with, and then we'll go to the live questions. So the first one has come in. I think this one's been directed to you, Pip, and then maybe Chris. So what sensors data do you use to track your success in achieving your climate and sustainability goals? Which is the most important? So that's from Peter in New South Wales.
Thanks for the question, Peter. It's a really good one. Which is the most important? You know, they're all important. You know, that's the thing about sustainability. It's those three pillars working in harmony, and you need all of them. I will let Chris do the talking about climate goals, but you know, from a sustainability perspective, we report a range of metrics. Some of our environmental indicators are things like use of recycled water, and that's something that we do very well at Port Kembla, for example. We look at material efficiency, very, very crudely speaking, the kind of inputs in versus outputs, and what that correlates to as a percentage, and again for Port Kembla it's very, very high. From a people perspective, we obviously have very strong safety targets and a very strong safety focus as an organisation. We also look at the diversity of our workforce, and gender diversity in particular is really important to BlueScope. And that's at all levels of the organisation, from the operations up to our exec lead team and to our board. All of those metrics and many more are published in our sustainability report, which is on our website. So encourage you to go and have a look at that if you're interested. Chris, do you want to speak to climate?
Yeah, sure. Look, we've got a number of targets which we outlined in that earlier video, and I guess at the heart of that is measuring both carbon intensity per tonne of steel and also overall carbon emissions. So for us on that front, like that's the hard target, and that's what we will be tracking. We have a target of 12% by 2030, and obviously a goal of getting to net zero by 2050. Yeah, hopefully that's the answer.
Excellent. Thank you. Thanks for that. And I would say for all the viewers, if you haven't had time to have a look on the BlueScope website, there is a lot of information on there, including the new climate and sustainability plans. Okay, so this next question is from Ambrose in Victoria. Thank you. I think this one might be for Spiros looking at it. Will BlueScope provide support for mechanical engineers and consultants to be able to recommend and quantify the benefits of sustainably sourced steel? Over to you, Spiros.
Right, thanks, Shelley. As Pip mentioned, there's I'm part of the hot roll products group, but there are two specification teams. There's also the coated products group that look after all the other coated products. And we specialize in buildings, infrastructure, and energy projects. So we are pretty much educating the industry on all matters relating to steel and steel solutions. But when it comes to sustainability, as Pip said, we can work with you on the design in the early stage, for example, to dematerialize structures using high-strength steels, where strength governs, or perhaps a customized section outside your standard range of products in terms of quantifying the environmental benefits, our EPDs, environmental product declarations. And the mass of steel saved, of course, as a result of using the higher grades. You can effectively calculate the embodied carbon savings. So the message here is really to talk to us in the early phase of the project, so we could best assist with standard or custom-made grades, plates and sections.
Great, thanks, Spiros. All right, the next question has come in from Margaret in Victoria. This is an interesting one, which I've heard asked before as well. What are the sustainability benefits to replace concrete structures with green steel structures? Pip, did you want to start with that one?
Sure, I've heard that one a lot too, Kelly. And to answer that one, I'd say, it really depends on what you're setting out to achieve with your structure. If you're thinking about sustainability over the life cycle of the structure, things like circularity, design for disassembly, reuse, recycling, then steel is obviously a very appealing option. If it's a question of embodied carbon, which it often is, then I would argue that no single material can get us to net zero, and every structure is different. I would also say that reducing embodied carbon is very much a shared goal in industry. And in my view, where we'll have the most success is those materials working in combination rather than pitting them against each other.
Very good. All right, so here's an interesting one. Maybe this one's for you, Chris. It's from Ashen in Asia. I think some of your presentation talked to this, but there's a more specific question. How does the production of steel impact the global greenhouse effect that is a major issue, as it is a process that uses significant energy? Is hydrogen a feasible offset to coal for steel production? Over to you.
Thanks, Ashen. The steel industry represents around about 7% of the world's total greenhouse gas emissions, so it is a significant contributor to that problem. If we talk about hydrogen's role in that, as we've sort of touched on in the presentation, if you can make hydrogen from green renewable energy, then essentially it will be carbon free. And so, how do you produce those processes that enable you to use that hydrogen? That will be the question, and that's the question that the industry is grappling with and working on. It is early stages. There has been demonstration plants built, many commitments to sort of scaling those plants up pretty rapidly over the next decade. But using hydrogen as a reductant versus coal, the challenge is, as I mentioned earlier, that endothermic versus exothermic reaction, and how do we grapple with changing that process and producing it with green renewable energy is a significant challenge, but one that the industry is taking on, and BlueScope specifically has started the process of developing the technologies that we're going to require to get there.
Okay, well, the next question I think follows on from that, so we might keep going, Chris. It's from Stephen in Queensland. He's asking, can you give a bit more detail about the hydrogen energy collaboration with Shell that you spoke to in the presentation, and to what extent this will reduce carbon intensity in your products?
So the collaboration that we've got in with Shell, we've started down the path of doing concept work to build a 10 megawatt electrolyser. Now, you would have heard earlier in the presentation that ultimately, if we want to transition the entire industry to the size that we have today, we're going to need something in excess of 1,000 megawatts. So the issue with hydrogen, as a lot of you will be aware, is the cost of it today is uneconomic. But to be able to make that transition from no hydrogen production today to over 1,000 megawatts in the future, you have to start somewhere. And so we BlueScope and Shell are committed to seeding the industry. How do we get the hydrogen industry started? It's not just for steel. We're looking at the alternative options for hydrogen as well within that collaboration, and we're well down the path of developing the concepts around putting a 10 megawatt electrolyser on our site in Port Kembla. So in our opinion, that's a seeding exercise to allow us to develop the hydrogen industry and to ultimately gain the scale and experience that we need to build that from. The biggest electrolyser that's active today in Australia is 1.25 megawatts. How do we go from that to many gigawatts? That's something that everyone is working on, and BlueScope and Shell are working on together. And we're going to start that with 10 megawatts with an intent to grow that as market grows and as technology improves.
Yeah, I think seeding that hydrogen industry, if we're really to get that scale up, is one of the significant things that needs to be done if we want to get that price down to make it really affordable and available to all for this net zero economy we seek. Okay, so the next one is from Joshua in New South Wales. Are you seeing a willingness, this is a good one, to pay for a green premium for steel products? So maybe Pippa, do you want to give that one a go?
Sure. I think it's fair to say we expect to see the demand for lower emission steel to grow, and we're obviously closely engaging with our customers and our stakeholders to ascertain, what that level of demand is. Lower emissions from steel can come in a number of forms, and that could be progressive direct abatement, as we've spoken to, how steel is used in design, as well as offsetting potentially. I mentioned our involvement with MECLA in my presentation, and that's one of the key ways that we're engaging with stakeholders on demand. And as I say, it's a dynamic space, so we will certainly continue to monitor and closely engage with our stakeholders on that.
Thank you. And following on from that, there's another question related to how can BlueScope steel contribute to Green Star certification? And I guess that demand for that green steel. Spiros, maybe you could help us with that one?
Yeah, sure. Well, there are a few different aspects of Green Star where using BlueScope steel can contribute to credit points. Pip mentioned our EPDs, which can contribute to credits relating to the life cycle assessment and upfront carbon emissions. Our EPDs and Green Rate certification for some of our products also contribute points under the new Responsible Products Framework. And we will see responsible steel recognized under this framework, as Pip mentioned earlier, in the not too distant future. For projects undergoing the previous design is built Green Star certification, we can also provide our certificates, the ISO 14001, and also our membership of the World Steel Climate Action Program. Green Star also has credits available for minimizing the urban heat island effect through specified SRI values. And a number of our COLORBOND steel colors comply with this requirement.
So flowing on from that question, there's another one here about that mentions the solar reflective index. And the question is coming from Stephen in Tasmania. Many councils require the reflective index to be stated for the exterior surface, such as COLORBOND, although COLORBOND states that the solar absorption level specifically. Is there a direct relationship between the reflective index and the solar absorption value? Is that one for you, Pippa?
Sure, and we're getting techie. So bear with me. I'll try and keep it high level. The short answer is yes. So solar absorbance is the solar radiation that's absorbed by a material. So in our case, let's say a COLORBOND steel roof. And solar reflectance is the ability of that material to reflect energy and not absorb it from the sun. The solar reflectance index, which some councils do regulate around, usually to minimise urban heat islands, it's a metric that's used to compare the coolness of roof surfaces, and it's calculated using both the solar reflectance and an additional metric called thermal emittance. Essentially, the higher the SRI, the cooler the roof will be in the sun. So to your question, Stephen, I think it was, we publish solar absorbance, but we do also publish the SRI of all our COLORBOND steel colours. And the best place to find that information is on our COLORBOND Studio website. I'm happy to send a link out to that, maybe with the recording for this session.
But it's available on the website anyway, isn't it, Philippa? Yeah.
On our website, the COLORBOND. Well, we have various websites, but the one that this particular information on is called colorbondstudio.com, I believe.
Okay, great. All right, here's another interesting one. This one's from Lee in Queensland. Are the financial and environmental sustainability goals of BlueScope well aligned? In other words, how does BlueScope ensure progress of climate action with a limited budget? Chris, do you want to give that one a go?
Yes, thanks, Kelly, and thanks, Lee. Well, I like to think they're very well aligned. Our companies publish this climate action report, and if you haven't had a chance to have a look at it, it sort of states the commitment that BlueScope's making around taking action on climate. And within that, there's a commitment from the company to spend 150 million in the first 5 years and up to 300 to 400 million over the first decade. And I would talk about that as a placeholder to give us the time to develop the pathway that we're going to need to. Like you saw in the presentation, there's many pathways to pursue and keep an eye on. And we're going to have to be able to be flexible and move as technology develops, and things that are successful are pursued further, and things that aren't, we leave behind. So for us, we're going to have to use the budget we've got to sort of develop that pathway. And in the time I've been in the industry, like that's a pretty big commitment to sort of progress down that path. And once we find the commercialised technologies, it's a matter of how do we then transition to that. And then that'll be a different question. So the strategy that we have, I think, is really, really well aligned to sort of making sure that the targets that we have in place are achievable and are achieved.
Great, thank you for that one. And you're in the hot seat again, because there's a specific question here about technology and commercialisation of that. So this one's from David in South Australia. The question is BlueScope considering adopting or investing in molten oxide electrolysis, which uses renewable electricity to turn iron ore into liquefied metal? Boston Metals believes it can deliver commercial quantities of green steel by 2025 without using hydrogen. So over to you.
Yeah, it's a good question, David. I have mentioned it in the presentation. Hopefully you spotted it in there. Boston Metals are presumed, for those that don't know, that this molten oxide electrolysis method. What I would say about it, they aren't claiming that it'll be at commercial quantities by 2025. They're in lab stage at the moment. They've got to scale up a couple of orders of magnitude yet. They do have a plan to build a demonstration plant by 2025, I believe, and that's probably the reference to 2025. Yep. That demonstration plant, to give you an idea of the scale, is about between 1,000 tonnes per year and 5,000 tonnes per year. What does that mean? In Port Kembla, we make 8,000 tonnes per day. So it's definitely a process that we're following and are keeping a very close eye on. It is in the early stages of development. And that is why we are also looking at this DRI hydrogen process a bit more on the pilot plant phase, as opposed to sort of a monitor the development of. So DRI hydrogen is probably a little bit further down the track, is what I would say, in terms of where the readiness for commercialisation is with the technologies. But certainly it's got potential and is one that is certainly within our realm of interest to closely monitor.
All right, and the next one's come in for you as well, Chris. So stay there. I guess, and this one's from Peter in New South Wales, and it's probably a question on a lot of people's mind. So with all the technologies and the development that needs to occur, what is the timeline that we can expect, green steel or, carbon-free steel being widely available and perhaps the more common choice in the Australian market? What's your best estimate on that?
If I'm being honest, it's probably in the 2040s. You will hear a lot of steel companies say different sorts of claims around that. Certainly, electric arc furnace steel making is a lower carbon intensity product, and you will see offers where they're potentially offsetting the carbon that they have to be able to deliver that. But as Pip has sort of explained in quite a bit of detail, the demand for steel will not be met by EAF steel making. So over time, you will see there are more offers around a carbon-free steel offer, but it certainly won't be predominant. And the technologies that we're pursuing, we are talking decades. It's not a few years. But what I would say is that where that can be accelerated and where the technology is developed to a point is certainly focus for us. We do have some fairly significant investment decisions to make over the next few years around our technology, but we need to be able to provide demand that exists within Australia, and those technologies that I've discussed are a few decades away. But we will be pursuing them as quickly as possible.
Yeah, and I think that question was asking, the most common choice. So there will be some other lower carbon steels in smaller volumes before that time. Yeah, but that's where we're at. Okay, I think that's very good. All right, so the next question, maybe this one's for you, Pip. It's from Ariel in Asia. How do you make the connection between your approach to sustainability, including climate action, and the reporting of the sustainability goals?
Sure. I presume we're talking about the UN Sustainable Development Goals. I touched on that in my presentation. So we have our 5 sustainability outcomes, and they are aligned to the relevant SDGs. So, at a very simple level, if you take our focus on climate action, there are a couple of SDGs that align with that. There is one called climate action, but there's also affordable and clean energy. But there are many other aligned goals that we have, areas of alignment around gender equality, health and well-being, decent work and economic growth. If that's of interest, then again, strongly encourage you to have a look at the sustainability report. It's a lengthy document, but that's quite early on in the piece.
Brilliant. Thanks, Philippa. Okay, there's another one here from George in New South Wales, and he's asking about the supply chain and greening of that. What strategies are you looking at for decarbonising bulk material transport? Is this one for you, Chris?
Sure. When we look at the things that I've been talking about today, we've been essentially talking about what we call Scope 1 and Scope 2 emissions. The transport arm of this sort of fits into Scope 3. So we're in the process of developing the reporting requirements you need to be able to do Scope 3. It is more difficult. But nonetheless, the transport arm of that is a very interesting topic. One of the things I didn't mention around the Shell arrangement is one of the most economic uses for hydrogen initially will be particularly truck haulage. So part of the development for that hydrogen electrolyser, that 10 megawatt, is to see the hydrogen truck haulage market with hydrogen. So we are talking to our partners in transport about how they might participate in that exercise as well. And what I would say is it's early days in that space, but how efficiently they can use hydrogen will be part of that. And there's no doubt that our transport partners over time have plans to decarbonise their fleets, and that'll depend on the type, whether it's shipping or rail or truck, how they go about doing that. But yeah, some exciting times ahead for us with the potential electrolyser and particularly truck mobility around Port Kembla.
Give you the opportunity, as you said, to seed some of those opportunities. All right, so the next one we have is from Mike in New South Wales. What information on sustainable steel production can be shared with industry networks? Yep, is this one for you?
Yeah, that's a nice quick one. I think, we've already signposted to quite a lot of information within BlueScope, within our reports, but if you want a more global perspective, I'd encourage you to look at the World Steel website. There's some really great information on the World Steel website, particularly around breakthrough technologies and timelines. Responsible Steel is obviously another good one, and the team at Responsible Steel are participating in a lot of webinars at the moment. So if you followed them on LinkedIn or something, then you probably get the updates to that. And the other one, just another shout out to MECLA and the Steel Working Group There's some existing information in the public domain already, and we'll be producing more as time goes on.
Great. So lots of sources of information available. So the next one is from Christopher in New South Wales. This is quite specific. What quantities of ground granulated blast furnace slag are available, and is this sufficient to supply demand? Chris, over to you.
Yeah, sure. I didn't write this for myself, so it's another Chris.
Christopher.
The answer on the quantity, I can't tell you straight off the top of my head, but what I can say is that all the ground granulated blast furnace slag is sold. So it's actually more of a supply issue than a demand issue. And certainly the reason that it's popular is that it can be used in the cement industry to decarbonise the cement product. So where ground granulated blast furnace slag is available, it's used up very rapidly. So I'm just looking at what the specific question was. There's not sufficient supply.
What quantities are available, and is it sufficient to supply demand?
No. Well,
no.
The demand outstrips the supply. Very, very much so.
All right. Well, I think that answers Christopher's question.
Okay. But I'd say the supply question is really about how much iron you make. So we're not making any more iron.
You never know. All right. This next one is from Robert in Western Australia. Will sustainability ever include an energy reduction target rather than just converting to renewables and then increasing energy use? Chris, I think you touched on that in your presentation. Over to you. I think we've lost you, Chris.
Sorry. When you think about the technologies that we're looking at to decarbonise our industry, all of them do require a lot of energy. So, and particularly electrification. So, I don't know that you talk about sustainability versus, the difference between sustainability and climate, I guess there are subtle differences. So, I'm sure you're aware there are some issues with recycling some of the renewable energy products that are around versus what's the carbon impact of utilising those renewable energies. And that's a balance that we're all going to have to face. Certainly, electrifying a lot of these processes is the key to decarbonising them, and there is going to have to be a reckoning about the balance of those things. But at this stage, it is about pursuing the carbon reduction and what are the technologies. It's not just solar. We are going to have to pursue other technologies because, as I mentioned earlier, it does need to be firmed renewable energy. So there will be other predominant types of energy that will have to come into the picture to be able to provide the level of electrification that's going to be needed in the future for the industry.
And I think really that, I think it was a really good point that you make there, is that the sustainability of the energy transition is something that's really just starting to come in the rhetoric more now that we're thinking about just, lowering the carbon intensity is not the full story. This is in the industry generally. There's an interesting question that this is one of our live questions now that's just come in from Trainer778. I'm not sure where they're from, but it follows on from that, Chris, in asking how much of the strategy is transformation versus optimization of current practices?
It's a really interesting question because I guess the job I've got is to pursue both. And the reason that we need to pursue both is we don't want to just sit on our hands and wait for this technology to deliver. We've actually got significant processes in place that we can do work on that will make an impact. So if you saw the presentation, we have it split between the 12% by 2030 goal and the net zero by 2050. But pursuing them both in parallel is the simple answer. And there's different thoughts about how we go about that. And really, we're trying to make sure that we're in a place to pursue the future technologies while we're working really hard and rapidly on what we've got and how we can make a difference with our current set of assets. So the balance at the moment is we're pursuing them both in parallel, and if I look at the amount of time I spend on both, it's pretty evenly split. And like as much fun as looking at the future stuff is, we've got some really hard, quick yards to do on the current practices as well.
And I guess, Chris, just even the fact that BlueScope has such a large team in this area just shows how much work there is in, I guess, meeting this challenge.
Yeah, and the commitment of 150 million in the first 5 years is a significant one, and it's giving me lots of scope to sort of transform current practices as well.
Okay, so this next one, Pippa, I think this one might be from you. It's come from Jeff Dyer, and he's asking, how do BlueScope see climate change events impacting their product performance? What new technologies are being considered to improve your products?
That's a great question, Jeff. I think one of the great things about steel is inherently it's very resilient and durable. So in terms of standing up to the effects of climate change, and if we think about bushfire, for example, our products can play a key role in bushfire resilience. In terms of new technologies, I would love to be able to share with you what our R&D team is working on, but that information is very closely held. But from a sustainability perspective, obviously the opportunities that they're looking at are around emissions reduction, waste reductions, solar absorption, some of the things that we've touched on already, but I'm afraid I'm not at liberty to divulge further.
It's certainly work being done in that area.
Yeah.
Okay, this is one that I think for Chris. It's also actually from Trainer 778. It says, what is the cost of greenhouse gas emissions internalized at BlueScope versus the expected cost of climate change? Not an easy one.
No, it's not an easy one. But to give you the real detailed answer, I urge you to go have a look at our climate action report. We consider a number of scenarios when we're looking at what our decarbonisation pathways are. And when we're looking at our investment, we're essentially putting a carbon overlay of what we think the future price of carbon may be under a number of scenarios. And that's helping to guide us on our decision-making process. So for the detailed answer, please refer to the climate action report. For the simple answer, we use a carbon overlay to help us to make an assessment on the viability of different transformative processes.
Excellent, thank you. And we're nearly getting to the end of the session, so we might be at some of our last questions. This one's for Philippa from Emily Gentilini in Brisbane. Has BlueScope considered offering their products as a service or any other circular economy business models?
Oh, well, that's a really exciting question. I personally get very excited about the circular economy and circular business models. And I think at the moment, that kind of service model works well with products with a shorter lifetime. When you think about steel, we're hoping that our products are in situ for decades. I think potentially the shorter term opportunity for steel is in reuse, another really critical part of the circular economy. So the concept of buildings as material banks, and I spoke before about designing for disassembly. I think that's probably where the immediate opportunity lies for steel.
Excellent way, I think, to finish with that one. Thanks, Philippa. Well, that's all the time we have today. So please join me once again in thanking Chris, Philippa, and Spiros for their time and insights shared in the session today. I'd also like to thank Engineers Australia and their industry partner BlueScope for making today's webinar possible. We'd appreciate your feedback on the program today to help us improve and plan future sessions. Please complete the short feedback form, which is linked to the description box below. Thanks again for joining us, and we hope to see you at the next webinar of the Thought Leaders series.